right, so page 6 gives you problems that combine all types of factoring. The thing you want to keep in mind, and think about that factoring flow chart we made where you input your polynomial and then there's multiple steps that come off of it, so just giving you this visual off to the side. Reminder, the first type of factoring, you always want to try and factor using GCF. In this case, we won't be able to factor very well without doing GCF first. So if I look at all three terms, what do they all have in common? Well, I know 5, 10, and 40 can be divided by 5 as the largest number that divides all of them. And then also we can take an x out of all three terms. So if we take 5x as our GCF, we're left with x squared minus 2x and minus 8. Okay, so we want to take this GCF and we're going to kind of hold it out to the side here, and we want to see, can we factor what is left? So what do we have as far as what kind of polynomial? We have a trinomial. So to do a trinomial, we need to do our cross puzzle. X squared times negative 8 gives us negative 8x squared. So we want to say what multiplies to be negative 8? And adds to be that middle term, negative 2. So we're unfoiling because we have a trinomial. So factors of 8, 1 and 8, 2 and 4. I'm going to choose 2 and 4, 2 and negative 4 because I want to make negative 2. So this middle term will get split up into negative 4x, positive 2x, and that first and last term stay the same. I'm going to circle for myself this GCF here so that I do remember at the end to bring that GCF along to my final answer. Okay, so to finish off this factoring, the GCF is x. I'm left with x minus 4. The GCF of the second group is positive 2, and I'm left with x minus 4. So my factors are, because I have matching x minus 4s there, I have x minus 4, x plus 2, and I'm going to remember to bring down my GCF of 5x. So if I were to check this and multiply this polynomial all out, 5x times x minus 4 times x plus 2, remembering to multiply just one pair at a time. Don't try and multiply everything together at the same time. Multiplying all of these out, I should get back to that original polynomial.